Okay, this is part one of a series of videos talking about how to use what my friend Zach Cron calls point rig geometry in Revit 2013 to create a broad structural thrust arch, sort of a parabolic or catenary arch. Those are different things, but they superficially the same, visually the same to architects. So I'm in the conceptual mass environment, and the nice thing about the conceptual mass environment that differs from project environment is that you can actually see your reference planes and your levels, and that's very handy when you're developing a geometry with points or reference lines. So the problem here is, or the design problem is how does one establish a kind of mathematical vehicle for manipulating a long, broad structural arch and in this kind of environment. So I'm going to do it one way really quickly that I think is interesting, but and then I'm going to do it another way that I think is a little more interesting. So the first way, what I'm going to do is I'm going to hold the level, and I'm going to hold Control while I'm dragging, and I'm going to start dragging a few planes up into the air. I'm going to nest some reference points on these levels. Now remember, if I if I have a current level, it's going to be blue. If I click and hold on another level, or click and hold on another reference plane, it becomes my working plane. So I'll start on level 1, and I'll use my reference points, and I'll create, let's say, 3 points. And then I'll click and hold level 2, and I'll do 3 here, 3 here, and I'll click level 3, and do 3 here, and maybe go back to 1, and do 3 down over here. So you see I'm sort of forming the bones of an arch. Now what I'm going to do is I'm going to actually create transverse ribs through which I'll loft a shape. And I'm going to use the spline through tools point. So I've selected my points and click spline through. Whoops, excuse me. I'm going to select my points and click spline through points. And this is actually creating, you have to be careful, watch if I accidentally select a point that I don't really want in there, it'll make a weird loop-de-doo. This might be easier in plan. You see what this is actually making are model lines. Now remember, the distinction between a model line and a reference line is that a model line will become part of your geometry and sort of dissolve if you erase it, whereas reference elements will remain intact. And there's a slight behavioral change after you've actually created something, but I'll talk about that later. So now I've selected these lines, and I'm going to, just because I want to keep them for a while, I'm going to go down to their properties and change them into reference lines. So now you see each one has an end plane, so you can, if you want to begin to set geometries on the end planes of the reference line, you can begin to choose them. This is looking for the point. There's the end of my reference line. So, and if I show you that, you see what it's done. It's picked that guy. But I don't want to do that right now. What I'm going to do is I'm going to pick each of these reference lines. Sorry, I'm going to turn off the show so my bottom reference plane isn't blue. I'm going to pick each one of these reference lines, and I'm going to create form. Unable to create form element. That's interesting, and I'm glad I could show that to you. I found there's a weird anomaly that if all of your points are coplanar, for some reason you can't do that initial lofting. I don't know why that is, but it's kind of, I'm glad that I was able to show you that so it doesn't drive you crazy. So I'm going to just take the 2 midpoints of the end lines and see if maybe that will let me create this loft. No, so maybe I need to do that for each one of these guys. Just pull one of the points out of plane. Let's try it again. There we go. So isn't that interesting that it kind of hiccups or coughs when you do that? Now, part of what I'm trying to explain is that when you're establishing a structural arch, usually we think of these things in terms of its longitudinal section, and of course this is a little bit peculiar looking. So I'm going to kind of try and get these things organized in some way. I'm going to grab maybe this reference plane and control drag out a few copies, and I can start to align these points. If I do a multiple alignment, I can align some of these points. Oh, they're not going. Funny. Sometimes these things don't behave. So I'll grab each one and I'll slide them over and lock them to a point. So I can kind of start out with, like, you know, an unwiggly arch and establish my primary geometry. And I'll do that for each of the midpoints of this. This might be easier to see if I go to wireframe for a moment. And you see this thing is, the form is going to start to calm down because I'm essentially making a cylindrical shape. And there's so much geometry here, I'm finding myself having to tab. If you hear me clicking, that's what I'm doing. I'm trying to find those points and slide them over. For some reason I'm not getting a shape handle on that guy. Don't know why that is, but let me go back and take a look at that. This guy's got a shape handle. Oh, there we go. Okay, so now these guys are kind of in a straight line, but they're still kind of up in the air. Now remember I had said I'd lay these points on each of these reference planes, and the cool thing about that is when you want to start driving the geometry, let's say I drive this up to 15 meters, it's going to pull these points upward. Now why did I sort of pull this midpoint off of the plane, and why is it still going upward? Because each of these points has a characteristic that when it's been laid onto a reference plane, it's got an offset number. So that's kind of another driver, and that could be drivers that you use individually. Like in this case, maybe I'll make it 3 meters and apply it. Maybe I'll actually make all those center point 3 meters. Come down here and set their offset to 3 meters, and they're going to be offset 3 meters from whatever plane they're hosted on. So now you see I've kind of made by aligning my points on reference planes and making that fixed distance between each point in its plane, I've created kind of cylindrical arch. Now of course my reference plane, they're not locked to that reference plane, so if I move it, I've sort of not taken advantage of some functionality there, but you get the idea. And those offsets are very powerful. They can be plugged in as a dummy number, or I can actually add a parameter to my conceptual mass family, which is kind of cool because if you push it back into a project file, then you can click on this geometry and begin inputting numbers within the context of your project file. And so I strongly recommend, and in fact I'll do it for you right now. Let's just say the height of the longitudinal height of the vault. I'll parameterize that. No, not default elevation. I'm going to add a parameter and call it mid height. And I'm actually going to make it an instance parameter. It's with mass elements. It doesn't. You don't have multiple mass elements. So this just makes it a little more accessible. It'll be accessible directly through the properties dialog box of the project. So I've done that, and I actually haven't started a project, but let me do that. I'll do a new project and jump up and pick a metric project. And it is empty. So if I go back into my thrust arch family, remember this is a conceptual mass family, so it's an RFA, and I'm going to load that into the project. It's funny. I'm going to place this. I'm at level 1. Funny thing about the default in Revit is that it sees mass elements as being sort of underlay, so they're always invisible in all your views. The category is hidden. But just for what it's worth, let me show you how this behaves. I'm going to put it into shade view, and I've loaded it into my mass, or excuse me, into my project. Now I'm not seeing all the construction points, but they're there. And you'll see that that vault mid-height parameter is right here. So let's jack it way up. I'm going to double it in height and apply it. So now I'm inside of a project, and I've got this geometry, and I've got this, a list of potential parameters that are functioning to show me in the context of, whatever it is. If it's a cityscape, or if this is a canopy in front of a building, you can kind of play with it. So that's the end of video 1, and I'm going to do some more stuff in video 2. I hope you'll join me for that.